Evaluate the integral of x sine inverse of x dx. So what I'm going to do is I'm going to use the integration by parts, and I'll just get to make it so simple by also deriving the formula itself. So when you're talking of the derivative d over dx of uv, we're talking of the derivative of a product function. We know that this gives us the derivative. First we're going to maintain a v when you've got two functions, and then you find the derivative of u, and then we are going to maintain u, we find the derivative of v. Now since v is dx is common in everything, I'll just say this is d uv being equal to v du, and then plus u dv. Okay, from this point I'm going to integrate everything. I'm going to introduce integral on every part. Now from here we know that the integral of 1 with respect to x, this is simply x. The integral of 1 with respect to y, this is y. I could have well just said that the integral of dx, because 1, there's no good showing that this is equal to what, x, and then the integral of dy is equal to y. The integral of dt is equal to t. Therefore the integral of duv is going to be equal to uv. So where there is integral of duv, I'm just going to put uv. So this is going to be uv being equal to integral. Now for this one, we're talking about the integral of v with respect to u, so I can't integrate that. I'll just leave it like v du, and then plus the integral of u dv. Now from here, since u comes first in the alphabet, I'm going to maintain this. I'm going to take this portion the other side. So that is going to be uv minus integral of v du being equal to integral of u dv. Therefore the formula for integration by parts, the integral of u dv is equal to uv minus the integral of v du. So this is the formula. I've just made the second part sub to the formula. So this is what we are going to use to work out this question present here. And now we need to always make sure that u is something that we can easily differentiate. And if we check in the formula itself, just this part is what we have on the question there. And so we need to make sure that u is something that we can easily differentiate, and then dv is something that we can easily integrate. Between x and sine inverse of x, which one can we easily differentiate? Which one can we easily integrate? So we can't easily integrate this one, but we can easily differentiate it. So I'm going to make this one to be my u. So I'll say u is going to be equal to sine inverse of x. That means dv is going to be equal to, I'll get the x, but the whatsoever that we get as dv always carries the dx. So that will be dv is equal to x dx. So I just got this one, which is here. That's the one I said it is my u. So from here I'm going to find du. Du is simply the derivative. So it's simply du over dx. That's what we are finding, the derivative of u with respect to x. And whenever we're talking about sine inverse, this is always 1 over the square root of 1 minus x squared. Well, if we are not able to do this one, we can check out the video in the description. That is going to give us the link to how to integrate sine inverse. And now, for us to be able to get v alone here, I'm going to integrate both sides. I'll integrate here, I'll also integrate here. Just as we saw earlier, the integral of dv is a v. And so v is going to be equal to the integral of x. This is simply x squared over 2. We simply add a 2, a 1 to the power, and then divide by the same power that we get. And now that we have got this, I'm now going to write the formula. The integral of u dv is equal to uv minus the integral of v du. And in this case, the equation is the integral of u. So x sine inverse of x dx. And that is going to be equal to, what is u? Well, u is here, sine inverse of x. Okay, so that is going to be sine inverse of x. And then we're multiplying this by v. What is v? Well, we've already found out what v is. That is x squared divided by 2. And then minus from the formula, minus the integral of v. What is v? That is x squared divided by 2. And then du. But what is du? Well, what I'm going to do here, I'll make du the subject of the formula. And so I'm going to multiply both sides by dx. So this dx which is in the denominator here is going to multiply, cross multiply this side. So it is going to be this side. So where there is du, I'm going to put the whole of this thing because that is du. So that is going to be what? 1 divided by the square root of 1 minus x squared, and then I'll put here dx. And so just to make it neat, this is going, I'll put the x squared in front over 2 and then sine inverse of x minus, this is a 2, that a constant, I can take it outside the integral, that will be 1 over 2, and then we're going to have integral, this x squared can multiply with the 1 on top, that is going to be x squared, and then divided by 1 minus x squared. Of course this is in a square root, and then dx. So our aim now is to find the integral of what we have here. So I'll just clean up. Now again, we want to find the integral of this second part. How do we get to find the integral of that? Well, we could think of u substitution, but we can't perform the u substitution here. It will be very tricky. U substitution is used when we are talking of things which differ by 1. The powers of x differ by 1. But these are the same, and if they are same powers, you can think of change of variables, but these are squared functions. They also be very tricky unless if they were linear functions. And so whenever we see something in this form, 1 minus x squared, I want to show us how where it comes from. If we are talking about identities, we are starting with the first identity. We know that sec x is the same as 1 over cos x. So if I square this, I also square 1, but 1 squared is still 1, I also square cos. And we also know that 1 is the same as sin squared x plus cos squared x, and then divided by cos squared x. And therefore this is giving us that sec squared x is equal to sin squared over cos squared is what? Is a tan squared x. And then plus cos squared over cos squared is a what? Is a 1. So whenever we are talking about an integral of something that is in the form where we have got first a number like x squared and then a 1. Or this cannot be always a 1. It can be any square number. Whenever we're talking about the integral of this, we can always equate x to what? To tan. Okay? Now, if I make tan the subject of the formula, then it is going to be tan squared x being equal to, I'll take 1 the other side, that is going to be sec squared x minus 1 becomes negative 1. Whenever we've got the integral of something that is in the form x squared minus 1, okay, where we've got a difference of two squares, but what is starting is first the variable and then the number. This can also be x squared minus 4. 4 is a square number. X squared minus 9. 9 is a square number. So everything that is in this form, we can always equate x to what? To sec. Okay, to sec. We can always do that. So you can say let x be equal to sec x, or x squared be equal to sec squared x. Now if you talk of the very first identity, sine squared x plus cos squared x being equal to 1, I can take sin the other side. That will give us x squared x being equal to 1 minus sin squared x. Whenever we've got something, the integral of a square number minus x squared, it can be any number. Whenever we are starting with a square number and then x, we can always equate x to what? To sine inverse. So these are some things that we need to know when we're talking about a difference and the sum of square numbers on integration. And so for this one, we have got 1 minus x squared. That means we are going to equate x to what? To sine. Okay, so we're going to say let x be equal to sine So x is going to be equal to sine. Now, this is x, but sine what? What are we going to equate? Well, we can just say sine of anything. Just anything, just. So we can just say let x be equal to sine u, but we shouldn't let this again be x because this is already x. So we can just say sine of anything. We don't care what that is. It's our choice to choose. Okay. And so from here, then we are going to go on and replace where there is what? Where there is x squared. That means if x is sine of u, that means x squared is going to be equal to what? Sine squared of u. I've just squared both sides. And so writing this again, this is going to be equal to, I'm not writing this again, I'll just write this second part. So this is going to be x squared divided by 2 and then sine inverse of x minus 1 over 2. And then we've got the integral, or I can simply write it like this, 1 over 2. The integral, where there is x squared, I'm going to put sine squared of u divided by the square root. And where there is, this is also x squared, I'll put what? Sine squared. So that is going to be square root of 1 minus cosine squared of u. Okay, and then now we have got dx. We can see that we've expressed everything in terms of u. So even the dx, we need to change it. So I'm going to differentiate from this point. So dx is going to be equal to, what's the derivative of sine? Well, it's a very simple table that we use. Take the x-axis as sine, the negative as negative sine, y-axis as cosine, the negative as negative cosine. And so moving in this direction, then we are differentiating. So the derivative of sine is cosine. We keep u the same way it is. But this was supposed to be dx over du. Instead of me saying over du, I'll put the du this side. Okay, in that manner. So where there was dx, I'm going to put cosine of u du. And so this is equal to x squared sine inverse of x divided by 2 and then minus 1 over 2 the integral of 1 minus, again I think I've gotten to change something here which I wasn't supposed to put. There was x squared here, and x squared is sine squared, not cos squared. So that is just an error when writing. I think I mentioned sine and I wrote cosine. So that is again, okay, sine squared u. Now we know 1 minus sine squared from the first identity. Sine squared plus cos squared is equal to 1. That means 1 minus sine squared is what? Cos squared. So we have the square root of cos squared u. And the square root and the square will cancel out. So we'll just remain with a cos u down. And that cos u which will be down. So what we're going to have is sine squared u and then cos u divided by cos u and then du. So this and this will be able to cancel out. And so what will remain with is x squared sine inverse of x divided by 2 minus 1 over 2 integral of sine squared u and then du. Now again, it is very difficult for us to get to find the integral of sine squared. So it is just difficult to find the integral of a trig ratio that is squared unless a double angle. So I'm not rubbing this because we have to use it later. So let me just write here x is equal to sine of u. So I can just put it there. So we're going to express sine squared in terms of double angles. We know that cosine of 2u, let me use x. Cosine of 2x is the same as what? Cosine squared x minus sine squared x. This is a double angle formula. So I'm going to put where there's cosine squared, I will replace with 1 minus sine squared. So this is going to give us cosine 2x being equal to 1 minus sine squared x, and then we've got another minus sine squared x. Of course, this is x, not u. So this and this will give us a 2 sine squared x. So that will be cosine 2x being equal to 1 minus 2 sine squared x. I'm going to take this one this side. I'm going to bring this one this side. So it becomes positive 2 sine squared x being equal to 1 minus cos 2x. Dividing both sides by a 2, sine squared x is going to be equal to 1 minus cos 2x over 2. So this is what we are going to replace here. But in this case, we just have u here, not x. So we're going to use u. So that's the identity that we're going to replace. I just wanted to derive it, otherwise that's an identity that we should always have in mind. So this is going to be equal to cos x squared sine inverse of x divided by 2 and then minus 1 over 2 integral. Where there is sine u, we are putting 1 minus cosine of 2u and then divided by a 2. We can now put du at the end. At this point I can simply remove a 2 because it's a constant, and so this will be x squared sine inverse of x divided by 2 minus this 2. If I remove it, to multiply with this 2, so that will become 1 over 4, and then integral of 1 minus cosine of 2u and then du. So from this level we can now integrate. So this is x squared sine inverse of x divided by 2 minus 1 over 4. I'll put it like that. The integral of 1 with respect to u will be 1u, which is simply u, minus the integral of cos, just a simple table which I drew earlier. The x-axis as sine, negative x as negative sine, y-axis as cosine, and then negative cosine. Going in this direction is integrating, but taking the opposite direction, going in this direction is differentiating. Taking the opposite direction is integrating. So here we have cos. When we get to integrate cos, we are going to get sine. So where there is cos, I'm going to put sine. The angle, keep it the same way it is. But even if we are integrating, get to differentiate the angle. The derivative of 2u with respect to u is going to be a 2. But instead of multiplying by a 2, we're going to divide by a 2. Okay, so that is going to be it. And then we'll simply add a constant c here. That will be the integral. Now we have got a combination of x and u. So all we are going to do is to replace where there is u. We replace back what? Replace back x. Okay. And so this is going to be equal to x squared sine inverse of x divided by 2 minus 1 over 4 u minus, now this double angle, I'm going to split it. What is sine 2u? Well, again, I just don't want to do it direct for the sake of reminding if we've forgotten. When you're talking about double angles, sine of 2x is equal to 2 sine x cosine x. So where there is sine of 2u, we are going to put 2 sine u cosine u. So that is going to be 2 sine u cosine u and then divided by 2 plus a constant c. So I'll just write it now on top here. That is going to be x squared and then sine inverse of x divided by 2 minus 1 over 4. We have a u and then minus this 2 and this 2 can cancel out, so that will be sine of u cosine of u and then plus a c. So from this point now, let's proceed and get to substitute where there is u. Now here we are. X is what? We can see that x is this sine u. But how do we get u alone? So we need to take sine the other side. So in other words, it will be sine inverse of x being equal to u. Just like when we have got sine of 30 is half, that means sine inverse of half is 30. So if sine of u is x, then sine inverse of x is u. So this is going to be equal to x squared sine inverse of x divided by 2, and then minus 1 over 4. Where there is u, we are going to put, that is sine inverse of x minus, now here we have got sine of u and then cosine of u. Well, that is going to be a little trick. What do we get to substitute? Where there was u, we substituted direct. Now think of it, if we get to put where there is u here, we put sine inverse of x. So it will be sine, where there is u, we put sine inverse of x. What are we going to get here? We are multiplying a function by its inverse. You simply get what? X. So that is what we are going to get. We simply get x. And then here now where there is u, we replace sine inverse. So what we are going to have is cos and then sine inverse of x. That is what we are going to have. But here we can't cancel out anything. What are we going to do? So in a case like this one, we are going to use a certain identity. That is a very simple identity which you already know. We know that sine squared u plus cos squared u is equal to 1. So if I make cos squared u a subject of the formula, that would be cos squared u being equal to 1 minus sine squared u. And I want to remain with only cos, I'll square root both sides. So cos u is going to be equal to the square root of 1 minus sine squared u. So that is how it's going to be. But again, we know what is sine squared u. We see here that is sine u. That means if we get to square this, even the x is going to be what? Squared. And so where there is cos u, we are going to replace square root of 1 minus sine squared u. But what is sine squared u? Sine squared u is x squared. So that will be x squared at that point. And then plus a constant c. And we can simply distribute the 1 over 4. So that is going to be x squared sine inverse of x divided by 2 minus sine inverse of x divided by 4, and then negative times negative there, that is going to be a positive. This negative and this negative, that will be a positive. So that will be positive x over 4 and then square root of 1 minus x squared, and then plus a constant c. We have got sine inverse here, we've got sine inverse here. I can simply factorize out. So that will be sine inverse of x, and then we've got a 2 here, we've got a 2 here. I can also factorize out that. And so what will remain here is simply x squared. What remain here is a 1 over. Since this one has gone, we removed a 2, only a 2 is going to remain. And then we have got x over 4, and then square root of 1 minus x squared, then plus c. Well, and that is it for this video. Thank you so much for watching. Hope it was helpful. Enjoy your day.